agree.
I was just kidding. No, I didn't. Oh, it's a second. What?
What?
Wi-Fi looks riveted so oh, this is never mind.
Are you about ready? Or another minute? Another minute. I'll write that down. That's
No, I don't think so. Oh, it's oh, it's a fair. But still,
How we doing? Sorry, I'm a little slow. What is that? Okay, so here, this is a lot. I hope I gave you a big space to work in. Alrighty, so, golly, almost done. Now we'll talk it over. Do 12 over 12 squared is 112 is greater than 0. All right. Okay, so let's go back to the first one. For relative extrema test, or second derivative test for extrema, you do have to find not just the derivative, but where the derivative goes zero or flat spots, horizontal tangents. All right. I'm giving you an example of a very common mistake. Once people learn the first and second derivative test, and they get some kind of crazy Frankenstein's monster between the two tests that obviously doesn't work for either. So this is a common error. The person found the flat spots were positive and negative 1. Do you agree? Okay, they found the second derivative is 6x. Do you agree with that? Okay, then they conclude something like this. Y has a min at x equal 1 because y prime goes negative to positive and y double is greater than 0. Is that the first derivative test? Kind of. Is it also the second derivative test? Yeah, kind of. Is it either one very well? No. And so this is garbage. This would not wash. This, they're thinking first derivative test. That's the first derivative test where min is because the derivative goes negative to positive. Using concavity, that's the second derivative test. This actually satisfies neither test. So neither one will work. This is garbage. It is y has a min at x equal 1 because y prime is 0 and y double is positive. So please don't make some kind of mixture of the two first and second derivative tests. Done correctly, then the max would be y has a max at x equal negative 1 because y prime is 0 and y double is less than 0. Okay. 22a, did you find horizontal? Did you find the derivative correctly? Negative x over 4y.
Yes.
Did you find the horizontal tangent occurs when the top is 0? You get a vertical tangent if the bottom is 0. Okay, so we're looking where the top is 0. It does say coordinates, so not just x. You don't just say, hey, x equals 0 and stop. You have to find the y that goes with it. Y is plus or minus 3. Therefore, you have 2 points, 0, 3, or 0, negative 3, where you could have horizontal tangent. To take the second derivative, you need to use the quotient rule on the first derivative. Done fairly cleanly, you should get something like that after you find dy dx term as you go and plug in the derivative. You should get something like that for the second derivative. Check? All right. Did you get at the second derivative at 0, 3 a negative? And therefore concave down at 0, negative 3 and a max. Yes? Okay. And the second derivative at 0, negative 3 is positive and a min. Last but not least, let's put this all together with pre-calculus and verify this makes sense. Do you remember from your pre-calculus days last year what that is graphically? It's kind of like a circle, but multiplying by 4 would cause it to stretch. And so if you stretch a circle, you get an ellipse. It's an ellipse. The more common form is this. If you divide 36 over, you get y squared over 9 equals 1. It would be centered at the origin because there is no shift. The x changes from 1 to negative 1. The y changes from 3 to negative 3. It looks like that. Does it make sense that we have horizontal tangents at 0, 3 and 0, negative 3? And does it make sense that we have a max and a min? Wait. All that is like, are you with me? Okie dokie. Today's lesson is critical. Critical. You've got to be on your game today. Are you feeling fresh and smart? You've got to. Can you imagine if you couldn't factor? What chance would you have at doing many problems forevermore after? It would hurt you forever. Now that factoring is to algebra what U sub is to calculus. You cannot do much integration at all if you can't use it. U sub is the crucial skill to integration. You've got to be able to kill it. I'm not saying be good at it. I'm saying be great at it. Or don't even try. All right, so here we go. U sub. It's U substitution, but everybody calls it U sub. So use a U substitution, integrate a composite function / product. Now, U sub is an integration technique, but it's important to start to see where it comes from back with the derivative. It really comes from a chain rule. If I take the derivative on e to the sine of x, what does the derivative of e to the sine of x look like? Do you agree that's a function within a function?
Yes.
So it's chain rule. What's the outside function? E to the sine of x, and then times the derivative of the inside, cosine of x, all right? Today's lesson and use of is used to undo that kind of result. So today you might do something like this. E to the sine of x, cosine of x, what's the antiderivative? And hopefully you can tell me that is e to the sine of x. Now that didn't involve any use of because you knew the problem, all right? Use substitution is a technique of kind of compartmentalizing, breaking it into little pieces that makes a bigger problem easier. It goes like this. First of all, remember that when you get a chain rule, you'll get a product where you'll see a function within a function. Chain rule is a composite function or a function within a function, and you'll have this extra derivative term hanging off to the side as a product, right? Now, consider this thing. Say you are integrating cosine of x cubed times 3x squared. Now, you most definitely cannot just integrate cosine, integrate 3x squared. You can't do that. Just like you can't take the derivative of a product by just doing each little piece. You can't integrate a product by doing just each little piece. That's 100% no. You with me? Instead, you will do something like this by saying, geez, that looks like they did a chain rule problem. And that 3x squared probably came from when they took the derivative of, here's what you used to, x cubed. Okay, that probably was originally, that probably wasn't even there. That came up out of the chain rule. The idea then is you take this problem and make it a little cleaner by substituting in. You're going to let u equal the inside of the composite function. So you're going to let u equal, well, what is the inside of the composite? Let's start with the composite function. What's the composite function? The function within a function. Where's the function within a function, people? X cubed in cosine, okay? Therefore, u will be the inside of the composite function. So you'll let u equal x cubed, okay? After that, and I wish I would have put that on there. After that, you find the du for that choice. Now, that basically means if that was the original inside, then when they chain ruled it, they must have taken the derivative of that inside. Well, what is du? If u is x cubed, let's actually go du dx is, what's the derivative of that function with respect to x? 3x squared, which du then, if I move the dx over, would be 3x squared dx. Are you with me? All right, now at this point you're thinking, okay, I'm doing a lot of symbol stuff. Now the idea is that you substitute in for everything in the original problem. By that then, that's why they call it U-sub, obviously. The original problem had an integral, and I did nothing to replace it. Cosine, I'm not replacing with anything. Cosine's still there. What does get replaced is x cubed is going to be substituted in for with x cubed. Or sorry, with itself. With u, yeah? In place of x cubed, I put a u. In place of 3x squared, I put a du. Now the idea then is that your new integral is much simpler or much more simple. I don't know if simpler is a word, but you get the idea. Okay? You should, therefore, be able to easily integrate. What's the antiderivative of cosine u? Sine u plus c, integrate. You get sine u plus c. Now, the last thing is, the original problem was x. And so your answer should be x. So your last thing is then to sub back in for u. What is u equal? Sine of, what's u instead? X cubed plus c. Now does that check? If I took the derivative on that, would that equal cosine of x cubed 3x squared? Yeah, you can always take the derivative. You can see that, yeah, if I took the derivative on that, it would be a chain rule kind of situation. Derivative of the outside with the inside the same, times the derivative of the inside in all as well. Okay. So u sub is a way of undoing a chain rule derivative. Yes? Do you, just like any time when you integrate, du stands for this is a derivative term. So when you integrate, you're undoing the derivative, du goes away. It's kind of like an inverse. The inverse of a derivative is an antiderivative. So when I integrate, that du is vanished.
So then why do we find?
Because you could, if you didn't find du, then this would still be there. If I just subbed for this guy, then I'd have this unholy mixture of u's and x's, and I have to sub for everything in there. Okay, so it has to be all in u terms, including the differential. Good question. Okay. Now this will take a little bit of practice, and we're actually, this is so important that we're going to do it all day tomorrow too. We'll do a fun sheet on this tomorrow, and we'll gradually get harder. But let's start. Do you feel like you want to do one more together, or you get it? You want to try one on your own? One more together. Okay. So the idea is that you're seeing a product, and it feels like one is kind of the derivative of the other. If you see a product where one is the derivative of the other, then you should think u sub. This is a big mess. By substituting well, it'll be pretty clean. All right, so if we were to do this, the first thing we do is choose u. U is the inside of the composite. And so what shall we make u? Natural log of x. Okay, the inside, when I say composite, I mean function within a function. 1 over x is pretty much is what it is. But this, that's a function within a function. It's log within root. So that's where you should look. And your u is what's the inner function. So log is inside. So that's your u. You then say, what's the derivative that goes with it? Now, I did this in 2 steps before. I did du dx, then du. I separated the differentials in x. You can do that in 1 step. Just imagine taking the derivative du dx and moving over dx. So what is du? Now stop looking here. Now look at the problem you just made. If u is natural log, then du is the derivative of that, and the dx moved over. What's the derivative of log? 1 over x with a dx moved over. Now we have everything we need to substitute into the original problem. The integral is still there. The square root is still there. But in place of log goes u. We said that log is equivalent to u. So I'm going to substitute in, or u sub, the log. This whole thing is equivalent to the derivative of the inside. So what do I put in for that guy? 1 over x dx. That's du. Okay. That then is a much easier integral, and that is very much the objective, is to strip away the inside piece and get a cleaner piece. U to the 1/2 by the power rule with the antiderivative. U to the 3/2, and then divided by 3/2 or times 2/3. Do you agree? Plus c, and then the last thing I do is sub back for u. So 2/3 times log of x, 2/3. 3/2 plus c, and if this were homework, I probably wouldn't check. But if this were a test, I would check by taking the derivative. You follow? Okay, try the next 2 on your own. I will, or with your Math Amigos, I will be happy to come around and clarify. This is not easy, so please don't be bashful about asking questions. Just asking a question will save you a lot of struggles. This one's a little harder because it feels like there's a couple functions within the function. You should also ask yourself, which one looks like the derivative of which? That also helps.
It'd be like this. It would just be. Oh, that's actually
Accelerate your understanding by asking questions.
Oh wait, the inside.
So, your this whole tangent of x is zero. So it's not canceling.
I remember what I killed time through
For you to square.
as like a constant.
But I mean, if it look at it constantly, it'd be like this.
No, I'm confused.
Then you don't have to carry this. Oh wait. Oh. It makes sense.
All right. It's looking pretty good. Most people chose well. When you go to choose, you say which one looks like the derivative of which. Do you agree that secant squared is the derivative of tangent? That means secant squared will be the du, and tangent will be the u. So your choice should be u as tangent. Du then, or du dx, is secant squared. If I move over the dx, then secant squared dx is my du. With substitution, the integral's still there. Everything in here needs to be accounted for. You can't, have something missing from the original problem. The integral still needs to be there. The 3 still needs to be there. You're putting in for tangent u, the square needs to be there, and that whole thing is du. Your integral should be easier. If it's not, something's wrong. So what's the antiderivative of 3u squared? u cubed, then you sub back 4u with whatever it was, tangent. So did you get tangent cubed plus c? Okay, excellent. This, which looks like the derivative of which? I'm hoping you'll say 5x to the fourth looks like the derivative of x to the fifth, okay? So if that's the derivative, then that's going to be your du I'm feeling. My u should be x to the fifth. Therefore, du is 5x to the fourth dx. With substitution, if I put this and this, kind of together next to each other, they become the du, and it's sine of u du. What's the antiderivative of sine of u? Negative cosine of u plus c, then sub back negative cosine of x to the fifth plus c. How'd you do? Good. All right. Let's get gradually more difficult, and they're not huge steps. They're just little bits of difficulty, okay? Sometimes you get a number there that doesn't help you. It doesn't really hurt you. If that's the case, feel free to just move that out front and use sub at the same time. So for example, that's 7. It's coefficient. I can put it out front. So what is my u? Cosine or negative sine? Cosine, okay, because that's the function within a function. So we would let u equal cosine, and therefore du would have to be the derivative of cosine, which is negative sine of x dx, okay? Now, with substitution, then this becomes 7 out front, 1 over root u, and that du is over here. Write yourself a note, please. If you ever have a differential in the denominator of a fraction, you're pretty well screwed. You don't know how to do that. That's differential equations. You won't go there for quite some time. Your differential should always be in the numerator, and if it's not, you did it wrong. Okay. So if you see something like this, you're not in territory you want to be. Okay. That then is power rule-ish. U to the negative 1/2. What is the antiderivative of u to the negative 1/2? Raise it by 1, so u to the 1/2, and divide by the new. Dividing by half is the same as multiplying by the reciprocal. Do you agree with my antiderivative of 2u to the half?
Yes.
Okay. Altogether then, if I combine the coefficients into 14 and rewrite, it'd be something like 14 root sub back with what goes in for you, cosine or negative sine? All right. Now the point then is just if you have a coefficient, don't sweat it, just stash it out to the front. Okay? Try this one. The most important part of this is choosing you. You choose you by saying what's the inside of the composite, or which is the derivative, which is the original. This is all about chain rule. Undo. So what did you let u equal? Or what are you letting u equal? Negative 5x squared. Therefore, du is negative 10x dx. That's perfect. That's exactly what you want it to be. With that substitution, I pull up 4 out front. It becomes e to the u, and that whole thing is d. Perfect. What's the antiderivative of e to the u? E to the u. And then sub back 4e to the negative 5x squared plus c is u. You with me? Yes. Any coefficient can any time be pulled out. Even before when we were doing power rule, it's okay to pull out a constant factor out front of the input. The negative 10 actually got sub-4'd. I didn't pull it out. So this is a really good question. Why pull out the 4 and not the negative 10? They're both coefficients, right? I felt like that negative 10 was actually helping serve the purpose of the derivative of the inside. That negative 10 is part of my du. I want it to stay because it's part of that negative 5x squared's derivative. 4 has nothing to do with my u sub, absolutely nothing. And so I pull it out front because it's not doing any purpose. The negative 10 I want to stay because it helps. Does that make sense? Good question. Okay, now, the little bit harder case is then sometimes the du is not all pretty princess. It's not all perfect for you. You have to do a little bit of work, okay? So the du at times will have to be manipulated a little. Consider this one. Sine of 3x squared is great, x dx. It feels like it's kind of a derivative of one is the other, at least in terms of powers. Don't you agree the derivative of x squared is x? So it feels like power-wise, this is that kind of u sub k, right? There's a problem, however, in that I would expect there to be a 6 there, and there's not. Now let's talk about that. Let's start with just doing it like we normally would. U is which? Which would you make u? 3x squared. Perfect. You're already getting that mastered. That's awesome. What's du then? 6x dx. Now in terms of what I have versus what I don't have, do you agree I do have the x dx? And so I could put in for the x dx. What I don't have is the 6. And so to do that, you probably will need to get rid of the 6 and say, well, du over 6 is x dx. Then I have appearing what I actually have to substitute. Now if I go to substitute in then, the integral is still there, sine is still there. What goes inside for 3x squared? For 3x squared, we replace it with u. Now we need to substitute for x dx. What's x dx equal to? Du over 6. Or 1/6 du if you like. All right. Now, that's, the 1/6 is a little ugly, but it's okay because can't I just move that 1/6 out? Can I move a coefficient out? So no worries. What's the antiderivative of sine of u? Negative cosine of u plus a c. Cleaning it up, let's put the negative out front of the 6 and replace the u with 3x squared, and boom, there's my answer. Now that actually makes sense if I went to check it, because wouldn't you agree if I took the derivative on cosine of 3x squared, it would be negative sine of 3x squared, but I would normally get a 6x dx. I don't have a 6x dx there, so there must have been something to cancel out that 6. And that's why the 1/6 is achieving. You with me? Try, get it, or try another one together. Okay, so you do a little more of the talking. What's u? X cubed plus 1, the inside of the composite function. U is x cubed plus 1. What's du? 3x squared dx. Okay, look at what you have here, though. All you have is x squared dx, not the 3. So, what do? I want to be able to substitute exactly what I have. So I have x squared dx. I don't have that 3, so I'm going to divide that 3 over. And so when I go to substitute, I actually have what they have in the original problem. If I sub for every component, the roots or the integral stays, 1 stays, the fraction bar stays, the square root stays. In place of x cubed plus 1 goes u, and in place of x squared dx goes u over 3. I might do a little bit of cleanup to help my integration. The third I can pull out front. The u I could write as a power and integrate. What's the antiderivative of u to the negative 1/2? Raise it by 1, divide by the new. 2 u to the 1/2. 1 plus c So I get something like 2/3 root, what? X cubed plus 1 if I sub that for u plus c. Okay? Try the next one. This is pretty famous, obviously, integrating tangent. Good question. So this was a bit of a gotcha because, you know, they have one is the derivative on other on both levels, right? So I'll tell you this, you cannot make u sine. Absolutely cannot. Why not? If u is sine, what's d? Cosine, okay? And that means du is in the denominator, and you're in trouble. Okay? So you absolutely cannot let u be sine, you must be cosine, so that the du is in the numerator. Oops. How we doing? Do you agree that when you take the derivative of cosine, you get a negative that you really don't have in the original problem? So you have to pretend like it's kind of like the 3 over here. You have to move it over. You have a negative 1 here. You have to move it over. So you get negative du over u. And what's the antiderivative of, if you put out the negative 1 out front, what's the antiderivative of du over u? What's the antiderivative of 1 over u? Natural log of the absolute value of u. Okay? If you then sub back negative natural log of the absolute value of cosine plus c. That's your one form of the antiderivative of tangent. Typically, you would move the negative up front and call it c. We'll talk about that later. You with me? Alrighty. Now let's put a couple of skills together. Sometimes you're going to have stray coefficients that are worthless, and you won't have the coefficients that are there. Then you've just got a lot of manipulating to do. So check this one out. We're starting to get into a little higher level, but we've built up, so no big deal. It's just a lot of little skills you talked about. First, identify if this is a chain rule idea. I would identify if this is a chain rule idea if I feel like this is a product and one is the derivative of the other in terms of powers. Don't worry about the coefficient. The 4 doesn't bother me. The powers have to be right. Do you agree that the derivative of x to the 7th could be some x to the 6th-ish form?
Yes.
All right, so that's what makes it a useful problem. Then you say, all right, let's choose u. What is u? X to the 7th plus 2. You then find du. The du is? Okay, now don't look here. Don't look at the original problem. 7x to the 6th, all right? 7x to the 6th, dx. Now in terms of being able to substitute and all this good stuff, we have two little constant or coefficient issues. First of all, that 7, that's nowhere in the problem. All right? I have the x to the 6th, and we're cool there, but that's 7 is not there. So what should I do with it? Divide it over. So d over 7 equals x to the 6th dx. That's cool. The other issue is the 4. That's not there, I don't want it there, what do I do with that 4 if it's inside? What do we do with a stray meaningless coefficient here? If we didn't like that 4, we put it out front. Don't like the 7, put it out front. So the same goes here. If that 4 is not doing you any good, put it out front. All right? Then you should be good to go on substituting. This whole thing in the parentheses gets sub 4 with u to the 50th. And the 4 is out front, so we're cool there. X to the 6th dx. What does it get sub 4 with? Du over 7. Perfect. All right? Now that over 7 is a coefficient. I can move it out front and integrate it at the same time. I would have a 4/7. And then when I integrate u to the 50th, what's the antiderivative of u to the 50th? U to the 50, 1 over 51. Plus c. Last but not least, put it all together and substitute. What's 51 times 7? 357. And instead of u to the 51st power, I'm going to go back and call that x to the 7th plus 2 to the 51st power. It would be a shame to forget the constant integration after all that. You get it? Try one, please. Try one. I'll be walking around if you have a question, you didn't understand what I did or why I did it. Make sure you're on the right track. What's your U? 7 to X. You're doing fine. Keep going. When you do the chain rule.
Good morning, Devlin Jaguars. Please rise for the Pledge of Allegiance. Today begins. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All students, the weight room is now open from 3 to 4 every day after school.
Yes, please check the lost and found tables in the front lobby. We have a lot of missing items to be claimed.
Are you interested in aviation, art, business, engineering, or a security and intelligence career? Embry-Riddle Aeronautical University from Prescott, Arizona will be here during the 7th hour today. If interested, sign up in counseling.
Girls swimming and diving will be having a parent meeting at Carroll Dive this Thursday in the Denver cafeteria at 6:30 p.m. We look forward to seeing all of our families there to learn more about our program.
Because when I took the derivative of sin to X,
Everyone in the Devlin community, Wednesday is the last day to enter the Mayan favorite book drawing in the library. The prize is a $10 Amazon gift card. Hurry into the library and enter.
If you are interested in the UNC math competition, talk to your math teacher today.
That's
The
me.
test will be Thursday morning during the first and second period.
I remember that. You can miss first or second Thursday and not
Admission forms are now due to counseling for the CU Aerospace Engineering Lab Saturday, this Friday from 1 to 3 p.m. If you're thinking about a career in engineering and would like to create and make your own fidget spinner, this is a fun and unique opportunity. Ask your friends to join you. There's plenty of room.
Senior high students, this is the final day for ninth graders to meet with a counselor for the admission meeting during 7th hour. Students with last names A through O are required to report to the counseling office. Ninth graders with last names P through Z will report to room E100. Also, students that did not attend last week are required to do so today.
All high school students interested in auditioning for this year's musical murder mystery, Curtains. There will be an informational meeting this Wednesday, October 31st, immediately after school in the auditorium. The meeting will not go for more than 15 minutes. Audition materials will be available at that time. If you've never been involved in a film production, come see what it's all about. Try something new this year. You know, it's a good thing to try out.
Winter applicants who have not registered yet, please do so. You will not be able to try out until your registration is complete. The first day of practice is November 12th. Don't wait until then.
Today, seventh graders with the last name E. Lansky will report to the auditorium and meet Mr. Northway during 7th hour. Tomorrow, last name Mike True. Report to the auditorium. Seventh graders.
Jacqueline Jack. Congratulations.
That's a 4A and 5A state champions. State gymnastics competition this Thursday and Friday, November 1st and 2nd. Good luck, ladies.
Hey, tomorrow there's no lesson, it's just extra practice on each side. So keep 50 till tomorrow if you have questions. Have a good day.